Okay, so this is on the Unit 2 study guide, letter J, number 4. So we're trying to find the mass of the precipitate and the concentration of all ions in solution. So first let's figure out our reaction. So we have BaCl2 plus Na2SO4. We're going to make BaSO4 and 2NaCl. Okay, so this is going to be my precipitate. So for the first part, we've got to find grams of barium sulfate. Now we're given both reactants. This is a limiting reactant problem. But what we can do, we already know moles of each one, so we just got to compare. So I'm going to write the net ionic equation, which is Ba plus SO4 making BaSO4. That's the net ionic equation. Let's get rid of that. Okay, so as you can see, this is a 1-to-1 ratio of ions, so whichever one has less, that's going to be your limiting reactant. So as I can see, since we have 0.2 moles and 0.4 moles, this is going to be my limiting reactant, and this is going to be my excess reactant. Okay, so for the limiting reactant, we're going to take our, if I have 0.2 moles of barium, then I'm going to make 0.2 moles of barium sulfate. But we can do this in the stoichiometry setup. So we're going to convert from barium to barium sulfate to grams. So we have 1 mole of barium. You'll notice that for precipitation, sometimes it's easier to just work from the net ionic equation, not the full equation. So that's 1 mole of barium sulfate. Okay, and then we have 1 mole of this for how many grams of barium sulfate. So we got to calculate the molar mass, or Google it if we're lazy, but you should remember how to calculate it. But we're going to say it's 233.38 grams. So we just do a little math here, times this by 2, 46.7 grams of barium sulfate. All right, so now let's figure out how many of each ion are left in solution. So let's let's maybe group you all together. Okay, and let's scooch you over here. Okay, so now we gotta figure out how many ions are in solution. So if we think about our beaker over here, what's floating around? So we definitely have all of our spectra ions still floating around. So we've got sodium, we've got chlorines, and then our barium and sulfate made barium sulfate at the bottom, so there's precipitate. But because we used up all the barium, there's no more barium ions. That was our limiting reactant. So our excess reactant, though, our sulfate, well, let's make that S nicer, SO4 2-, is also floating around. Now, the Na and the Cl have not reacted, so they are still the initial amounts. But for SO4, we have to find out how much is left over after it reacts, because some of the sulfates are now in the precipitate. So let's do sodium and chlorine first, because they're easier, because they're just the same amount. So if I had 0.4 moles of Na2SO4, that means I have 0.8 moles of sodium ions, because we have 2 sodium ions per Na2SO4. So all I gotta do is divide that by our total liters, and since we added together 200 to 200, this whole thing should be 400 milliliters. So I divide by 0.4 liters, so that is 2 molarity for the sodium. Then we have 0.2 moles of barium chloride, which is the same as 4.4 moles of chlorine. It's the same thing, right? We have 2 chlorines per. We're going to divide that by 0.4, and we get 1 molar Cl-. Last but not least, the sulfates. So that's a little bit trickier. So let's move everything we've done, scooch it up, scooch it. Okay, so now let's do the sulfates. So we have to do like we would if we had an excess normally and we want to know how much is left over. So let's take our 0.2 bariums and convert. How much sulfate are we going to use for the 0.2 bariums? And we should really be writing our ions. We do ions, but whatever. Okay, so if we look at our net ionic equation again, there's 1 mole of barium for every 1 mole of sulfate because they're 1-to-1, barium sulfate. Which means if I need to use up 0.2 moles, I'm going to need 0.2 moles of sulfate. So this is how much gets used, is used up, converted to barium sulfate. So let's take our initial. So we have 0.4 moles of Na2SO4, which is the same as saying we have 0.4 moles of sulfate because there's only 1 sulfate in each one, right? So then we divide, so we just subtract that by our 0.2 that gets used up, and we get 0.2 moles of sulfate. So for now, that's how much is left over, and now we divide by our total liters, 0.4 liters, and we get that sulfate is 0.5 molar, SO4, 2 minus. So our answer should be 46.7 grams barium sulfate, 2 molar sodium, 1 molar chlorine, and 0.5 molar of that sulfate left over.